Hello friends, this is Jim here with Science Talk, and in this third video in my series of discussing oscillatory systems across the planet, I'm going to discuss here with you the Indian Ocean Dipole, also known as the IOD. And basically, get right to it. First, let's give some background on what the Indian Ocean is, some general conditions. From May through September, the wind blows from the southwest, and from November to February, it blows from the northeast. Warm sea surface temperature is on the eastern side, cooler on the western side. More freshwater input is on the eastern side than on the western side. Upwelling system is located off the west. A deeper thermocline is in the east than in the west, which explains the upwelling off the west because the thermocline is, or pycnocline, is slanted in that direction. Convection is higher over the eastern part and lesser over the west. Then we have what's called the Wertke jets, which over the equatorial Indian Ocean transport warmer upper layer water towards the east during April and May, and then in October, November. Heat content is higher on the eastern side than the west. Lower salinity is on the east than the west, which makes sense because we have more freshwater input on the eastern side than the western side. Okay. The IOD is also known as the Indian Niño, is an irregular oscillation of sea surface temperatures in which the western Indian Ocean becomes alternately warmer and then colder than the eastern part of the ocean. Monsoon in India is generally affected by the temperature between Bay of Bengal in the east and the Arabian Sea in the west. The IOD involves an aperiodic oscillation of sea surface temperatures between positive, neutral, and negative phases. A positive phase sees greater than average sea surface temperatures and greater precipitation in the western Indian Ocean region, with a corresponding cooling of waters in the eastern Indian Ocean, which tends to cause droughts in adjacent land areas of Indonesia and Australia. The negative phase of the IOD brings about the opposite condition, with warmer water and greater precipitation in the eastern Indian Ocean, cooler, drier conditions in the west. The IOD also affects the strength of monsoons over the Indian subcontinent. A significant positive IOD occurred in 97-98. Strong El Nino then, with another in 06. The IOD is one aspect of the general cycle of global climate interacting with ENSO in the Pacific Ocean. As I left off the second video, everything is interconnected. PDO, IPO, ENSO, IOD, AMO, NAO, they're all interconnected. The IOD phenomenon is first identified by climate researchers in '99. So it's only 20 years that we have actually been aware of this, or at least been able to define it and demonstrate its existence. Just like the NAO was discovered basically only about 10 years earlier than this. Excuse me, not the NAO, the PDO. Because Dr. Hare noticing the changes in salmon productivity. So the PDO was first described in about the late 80s, and then we had the IOD just before the turn of the new century. An average of 4 each positive negative IOD events occurred during each 30-year period, which each event lasting around 6 months. However, there have been 12 positive IODs since 1980, no negative events from 92 until a strong negative event in late 2010. The occurrence of consecutive positive IOD events is extremely rare, with only 2 such events recorded in 1913 and 1914, and 3 consecutive events from 06 to 08, which preceded the Black Saturday bushfires. Now, if you're saying, but if this is described in 99, how do we know about 1913, 1914? Because then, now that you know what you're looking for, you can go back into the data and says, aha, we can see the signals here. Whatever the parameters that you are examining, you can then basically extrapolate not only forward, but backwards. Modeling suggests that consecutive positive events could be expected to occur twice over a 1,000-year period. The positive IOD in 2007 evolved together with La Niña, which is a very rare phenomenon that has happened only once in the available historical records, 67. Usually, if you have a positive IOD, it's coupled with an El Niño event. A strong negative IOD developed in 2010, which coupled with a strong and concurrent La Niña, caused the 2010-2011 Queensland floods and the 2011 Victorian floods. Typically, that's what happened. Positive IOD coupled with El Niño, negative IOD coupled with La Niña. So the event in 67 was a rarity. In 2008, Neroli Abram used coral records from the eastern and western Indian Ocean to construct a coral dipole mode index extending back to 1846. This extended perspective on IOD behavior suggested a positive IOD event increased in strength and frequency during the 20th century. The effect on the Australian drought. 2009 study by Umenhofer et al. At the University of New South Wales Climate Change Research Center has demonstrated a significant correlation between the IOD and drought in the southern half of Australia, particularly the southeast. Every major southern drought since 1889 has coincided with positive neutral IOD fluctuation, including 1895 to 1902, 1937 to 45, basically covering World War II, and 95 to 2009 droughts. Excuse me. The research shows that when the IOD is in its negative phase with cool western Indian Ocean water and warm water off northwest Australia, the Timor Sea, winds are generated to pick up moisture from the ocean and then sweep down towards southern Australia to deliver higher rainfall. In the IOD positive phase, the pattern of ocean temperatures is reversed, weakening the winds, reducing the amount of moisture picked up and transported across Australia. The consequence is that rainfall in the southeast is well below average during periods of a positive IOD. The study also shows that the IOD has a much more significant effect on the rainfall pattern in Southeast Australia than ENSO in the Pacific, as already shown in several recent studies. However, ENSO does play a role. It is connected. Drought conditions tend to occur during El Niño, wet conditions during La Niña. A very recent study in 2018 by Hamid et al. At the University of Aizu simulated the impact of positive IOD event on Pacific surface wind and SST variations. They show that IOD-induced surface wind anomalies can produce El Niño-like SST anomalies, with the IOD's impact on SST being the strongest in the far eastern Pacific. They further demonstrated that IOD-ENSO interaction is key for the generation of super El Niños. Generally speaking, when IOD is in negative phase, it's coupled with La Niña, and the positive phase coupled with El Niño. That's the general summation. Effect on monsoons. When IOD is in positive phase, this favors monsoons with the result of heavy rainfall over Africa and India. And when it's in a negative phase, you get the abatement of the monsoons, or it ceases totally with dry conditions over Africa and India. So here it is. This is a dipole. That's what the two circles are, the dipole. Warm water, cool water. Okay. Strong El Niño, if you look at the over here. Okay. 1997, strong El Niño. So there it is. This is what identifies the Indian Ocean dipole, like two poles. Okay. Coupled ocean atmosphere in the Indian Ocean is characterized by anomalous cooling of sea surface temperatures in the southeastern equatorial Indian Ocean and anomalous warming sea surface temperatures in the western equatorial Indian Ocean. Associated with these changes, the normal convection situated over the eastern Indian Ocean warm pool shifts to the west and brings heavy rainfall over East Africa and severe drought forest fires over the Indonesian region. Okay, so when they're saying anomalous cooling of the sea surface temperature in the southeastern equatorial Indian Ocean, that's this right here. So that is in the positive dipole mode. Okay? And you have the warmer western equatorial Indian Ocean waters here. The negative, you have the exact flip-flop. And even off Japan, the warm the waters change in temperatures from warm to cool. Okay? The clouds represent the low pressure system and precipitation pattern. So let's review. Negative phase, monsoons abate or cease with dry conditions over Africa. Okay, when it's in the negative phase, coupled with La Nina. Okay, so let's again look at this. So this is the negative phase, right? And as I just showed you, monsoons abate or cease. So no monsoon. Look at this big cloud over India, right? Positive phase, big monsoon. See the rain right here. Okay, positive. So this is associated with El Nino. This is associated with La Nina. Right? Negative phase coupled with La Nina. IOD positive phase coupled with El Nino. So El Nino is taking place here with the positive phase. La Nina is taking place here. Also notice how there's a bit of precipitation over Australia, the whole continent. It's dry here. Okay? So that's kind of what's going on weather-wise. This is just a very detailed graph showing warming conditions in the Western Indian, cooling conditions here, high pressure system here, and then the reversal. You get the low pressure system this way. Now you'll note one thing. You see how this arrow is for the high pressure system? It's indicating a counterclockwise flow. That's because we're in the southern hemisphere. And Coriolis deflects it left in the southern hemisphere, such that high pressure systems that are counterclockwise in the southern hemisphere, clockwise in the northern hemisphere, low pressure systems in the southern hemisphere are clockwise, counterclockwise in the northern hemisphere. So this is Coriolis. But this is obviously the negative phase down here. This is the positive phase in the upper panel. Okay, top phase with drier conditions over Australia. Bottom panel is negative phase with wetter conditions over Australia. Right, there you go. Low pressure system brings precipitation, high pressure, sunny days. Top panel is negative phase of the IOD, coupled with La Nina with wetter conditions over Australia. Bottom panel is the positive phase of the IOD, coupled with the El Nino with drier conditions over Australia. There you have it. Now, I included this one here because it's showing what the equatorial thermocline / pycnocline is doing. Okay, and so this is the positive phase. We have warmer water here, cooler water here. Okay, here's the convection cell, right, going this way. Reduce rainfall, right? Well, the warmer water is creating a downwelling here. So it pushes the pycnocline down, but with the upwelling, it pushes the pycnocline up. Now, upwelling will bring nutrients to any potential biological productivity. And then you can see the opposite takes place during the negative phase, right? We see the switch in the temperature regimes, okay? And now the thermocline basically does a flip-flop, right? See how that changes? And you also notice that the direction of the convection cell also reverses, and now we get increased chance of rain. That basically is just tying in together all these different graphics that I've been showing you. That's positive phase and then the negative phase. And then this is just a little blow up of this one here. So you can showing the coupling with the SST and the atmosphere, right? Warmer water, you're going to have a higher rate of evaporation, so you get the updraft forming the clouds. So it's a low pressure system. And then the cell here, so you get the downwelling here. There's a high pressure system here, low pressure here, high pressure here, and then you get high pressure will also push down on the water. So and you get the increased chance of rain because you have low pressure and precipitation, right? If you take in warm water, you evaporate more readily, you got more moisture in the air, it's more likely going to precipitate out. And just yet another example of what's going on. This is looking more in the Indian Ocean per se, not really looking at Australia. But as you can see, you got drought condition in the negative phase. The monsoons are not in play here in India. Drought over Africa. Okay, this is in the negative phase, but you got heavy rains with the warmer water out, Indonesia, Polynesia area, etc. And when the positive phase, you got the heavy rains, you got the monsoon, you got the monsoons here again, the warmer water here, and then you have cooler water here, and you got drought conditions here. So you're gonna have a low pressure system here, high pressure here, low pressure here, high pressure here. And this is from WOI, or WHOI, Woods Hole Oceanographic Institute. And an index, okay? The Subtropical Indian Ocean Dipole Mode Index. So here's the negative phase, and here's the positive phase. And as you can see, it does oscillate. And this is from 1870 to 2017. They've reconstructed this. So the positive phase will be associated with El Nino, the negative phase with La Nina. And now this is from 2004 to 2019, the IOD index. So we're kind of honing in. And this is, kind of average in between here, maybe the kind of the neutral phase, if you will. And you can see where it gets really strongly negative or strongly positive here. And these are the months. So this is May, June, September. Wait a second. And yeah, so March. March, June, September, December, March, June, September, December. March, June, September, December. So that's showing the months. So this is like a monthly running average here. So March, June, September, December, that's 04, then 05 is the next coupling, and that kind of stuff. So that's what these letters are here, showing every quarterly, basically. They're doing a 3-month running average. And you can see how the index, if you look back at here, let's see, this starts in 04. So this is starting about here. And, we can see 06. It's kind of hard to get the scale. 06, yes, let's see, that's halfway. So that looks like 05, 06, which would appear to correspond to this 05, 06. Okay. And I showed this earlier, but this is just to, reiterate that Australia is wet during La Nina and dry during El Nino. So IOD is negative here, IOD is positive here. Now, I wanted to put in this diagram to show you the coupling between ENSO and the IOD. It shows the IOD in the negative phase, right? Cooler western waters here, warmer with the low pressure here, so you're going to get more precipitation. And then you have ENSO. Coupled with La Nina brings the wet conditions of Australia. Arrows that go up are from low pressure system. That's these guys here. Where they go down, they're forming high pressure systems. Right? High pressure system here, low pressure system here. And this Indonesian low, remember during a La Nina, shifts towards the west. El Nino, it would shift more eastward. Again, the coupling. Everything is tied together. Global wide. Okay. El Nino conditions, right? Here's the warm water. Here's the shift in the Indonesian low. So here's the low pressure system with the updraft, high pressure system with the downdraft, low, high pressure systems. And you notice high pressure system over Australia is dry. And of course, this would be warm water here, cool water here. This is the positive IOD. So you can see how everything just ties together. And here's that low pressure system, right? Updraft, low pressure system. Lots of rain here in Africa and the Indian subcontinent. And this low pressure is going to bring wet conditions to the southwest. So I brought in again the El Nino and La Nina. So El Nino is on the top, bottom is La Nina. and the cold phase. So kind of trying to tie my videos together before my next series goes over to the Atlantic side. The pressure increasing, warm water flows eastward. Okay, this is during El Nino. So sea level drops on the western side. You have a strong countercurrent. The trade winds are weak. Here's the jet stream. We get the warm water here, which means the thermocline / pycnocline is depressed, no upwelling. During the La Nina, the strength of the trade winds increase. Equatorial currents, which flow this way, are strong. The countercurrent weakens. Now we get the cool water, the upwelling. Okay? And then we get the low pressure here. Okay? Low pressure. So now we have the negative IOD, low pressure with the La Nina, rain over Australia. This is positive IOD with the El Nino, dry conditions over Australia. And now what also happens here, as the water is pushed this way, the water piles up. Here we create that gradient because it's on the equator, there's no Coriolis, so the water just flows straight. If the gradient was up here and water started flowing down, then as it flows this way, it deflects it to the right, you create a gyre like this. Here's some interesting URLs. They really go into in-depth discussion, interact with the IOD and ENSO, so you can look at that website for that information. For a discussion of the 2010-2011 La Nina effects on Australia, which includes a discussion on IOD and ENSO, you can use this website. .au is Australia, so this is Australian government. For a detailed discussion of the impact of IOD and ENSO on wheat yields in Australia. This is an interesting article. Okay, that's a little shorter video, but that's in a quick nutshell what's going on with the IOD, and especially with its interactions with ENSO. So that's the third video in this series. I'll be preparing soon upcoming videos. So I thank you for your time. I hope you're finding this series informative and interesting. And we'll talk soon. Hey folks, this is Jim here reminding you to please subscribe to my channel and please share my videos with others. Also remember to click the bell so that you know when I drop in a new video. I also ask that you please consider becoming a patron of my channel and support the work that I do by going to patreon.com/Science Talk with Jim Massa, each word separated by an underscore, and becoming a patron. It's asking for as little as $3 a month, cost of a cup of coffee, to support the work I do and keep my informative videos coming your way. Thank you for your support.